Okay, here we go. This is a little unusual. My name is Mike Hegeveld. I'm the program coordinator for the STEM program at Templeton. And we had originally planned to do a virtual, I guess, live STEM information night. And the recommendation we got actually from the tech group was that it's maybe prone to crashing and other problems, maybe people not being able to log on and so on. So the recommendation was to do it pre-recorded, which is a bit unusual. In all the years I've done this, I've never done it pre-recorded. So I'll see if I can get over the weirdness, and hopefully you can get over the weirdness as well. It's often nice to be able to see people directly. Another thing I want to recognize straight away is that some of you might be, well, hey, what if I want to ask questions? We'll honor that for sure. You can, at the very end, I'll make sure to share email and contact points. And then the questions that you give me, what I'll do is I'll put together a frequently asked questions page and post it to the same place that you would make applications and where this video is posted. And then that way, if you come back, within a day or so, I'll give people a little bit of time to put together questions. You should be able to see answers to your questions there. So we're going to get going. So I guess before we get started, I just wanted to recognize that we're working, living, and playing on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh Nation here at Templeton. We're right in the middle of it, and we're very lucky to be here. The way that I'm going to run this is I have a slideshow lined up. It's got some videos. It should be around, I'm hoping, 25 minutes, which is a real struggle for teachers, right, to reduce their talking to that level. And let's see how that goes. So here we go. And we're live. So the Templeton STEM program, I'm assuming that if you're here, it's because you're interested in seeing what the grade 8 cohort looks like and what you can expect if you were to apply to and be accepted to the STEM program. So I guess just before I get going, originally the plan was that Raza and I were going to present. Just because of the circumstance, I'll be presenting on my own, but Raza very much wanted to participate. He is currently the principal at Templeton Secondary. He's been in the board for 23 years and is a great addition to our school. It's really great to have him at Templeton. Myself, my name is Mike Hegeveld. I'm the STEM program coordinator and head of science here at Templeton. I actually live in the neighborhood, which is a benefit almost always. And I've been working in the school board for 20 years. My background is math and physics. And I've been at Templeton, about a dozen years. So this is what the agenda is going to look like. So, settle in if you, the beverage of your choice. We're looking at, I want to address sort of what is STEM, just to make sure everyone is on the same page. Then we're going to look at what does a day look like. So the idea, particularly if there are young people watching this, if you were here in the STEM program, what would it look like to go through on a day-to-day basis? And then once we've given you a good idea, that'll be the meat of it. Once we give you the idea of what it looks like and kind of a sense of what you could look forward to, then we'll get into some of the program highlights, like what, where does this lead to after grade 8 and so on. And then, of course, the details like how to apply and an opportunity to find some context for questions and answer. So STEM, almost everybody seems to know this now, so you've all been studying well. STEM stands for Science, Technology, Engineering, and Mathematics. It's an acronym. It's been around for a decade or possibly more. And what it really is that it's, in our case, it means interdisciplinary teaching through projects and cooperative groups. So that's really what it is. It's like, let's take these subjects that are traditionally separate, like science and math. That's how I grew up. I did my science and math differently separately, and my tech separately also. So the question that we asked a number of years ago is that, well, why can't these things be interdisciplinary? I mean, this science and math have got a lot in common, and so does tech. And so that was the intervention, like, let's do it. Let's put these together. So this is really a story about what advantages do you get when the subjects are put together. And also learning through projects. Many kids are motivated by projects. They have a really tangible goal that they're working towards, and it's fun to build things. And then the last piece, really, it's super important to us that people work in cooperative groups and that they have an opportunity to develop those really key skills about working together. Another big thing for us that's not always necessarily obvious to people who are new is that it's really important to us that the projects that we do are based in real world examples. So I've got a list of some here. You can read for yourself. Climate change is a big one. Things like free Wi-Fi everywhere, like what does that look like? Emergency response and technology involved with that, early warning, sustainable food practices, and so on, self-driving cars. We've got projects that at some level have touched on these kinds of topics, but that's where we always seek if we're looking for inspiration, and if students are looking for inspiration, it's really, do you see these things in the world around you? And that's what that's where we're working from. The other thing I think that's really important is that as much as possible, we're trying to embody the idea of the new curriculum, which is a movement toward competencies rather than directly, do you know this fact or that fact? So it's not that facts are not important, but the facts are the things that deliver and help you develop these really important skills that you're going to need in the future. So listed, they are critical thinking, being able to think creatively, your ability to communicate with other people. And sometimes that's just like simply interpersonal skills and making sure that you're being clear, but also like how to communicate within, like communicating science, for example, is different than communicating in English or social studies. So there are specific elements to communication that are important. And then personal and social responsibility. How do you learn strategies to be effective when you're working in groups? And looking at the impact that science, tech, and mathematics have on the society around us. So it really is, how do we get these subjects together to develop the competencies that we see in real jobs? I think another way maybe to think of it, there's an educational theorist or a famous educational psychologist who said the principal goal of education in schools should be that creating men and women who are capable of doing new things, not simply repeating what the other generations have done. And I mean, if we want to be meta about it, the fact that I'm having to do a presentation with no one in front of me is an indication that things change quickly and we have to be able to adapt. And I think almost everybody, I have 4 kids myself, and I really recognize that in my own kids, it's being flexible to new situations is just so important. And it's not that you don't need to know anything, but I think being able to adapt is really critical. And so that's why I like this quote. I think about it a lot when we do program planning and work with kids. So some quick facts about what the program looks like. We had our first cohort of 23 students in 2014. That was at the grade 11 and 12 level. Here we are in 2020, we've got 134 students, and it spans all grades, grade 8 to 12. A quarter of them are girls, and we have 4 staff instructors. So it's really grown, and the goal ultimately is to involve as many staff from these different disciplines as possible, and to really make sure that this way of doing things is available to as many people as possible. We've got about 150 developed projects over those years, so it's been really fun to see all these different things you can do. If you wanted to get an idea of what do the courses look like, so we're down to maybe some nuts and bolts already. Depending on what grade you're in, you do slightly different courses. But I think the easiest way maybe to think about it is that there's one course sort of per letter from the acronym. So in science every year, we sort of everywhere, well, where is science represented? Well, at the grade 8, 9, and 10 level, we just call it Science 10. You'll find that as you get into the senior levels, a lot of the stuff that we do and the subject expertise that we have as instructors leans sort of more in the direction of physics. Whoever's teaching those things is also the person who teaches the math. So you have fewer instructors. You have 2 instructors in total, somebody teaching science and teaching math. And then the second instructor is the one who's teaching the T and the E. So in this case, in grade 8, it's called ADST, which is your tech course. It's called ADST in grade 9 as well. And then the names change, but it really is around the interface of like how does technology apply to the STEM fields. There are also some graduation requirements. There's one called the CLE and CLC are graduation requirements that we do at the grade 10 and 12 level. So I think maybe the most important thing to notice here is that your schedule would consist of 3 courses are banded together, and you're with a cohort of students in those 3 courses, and you have 2 instructors, one for your science and math and one for your ADST. And then that goes up to 4 courses in the senior. And then the other courses are, of course, from the regular schedule, so English and PE and so on. If you wanted to get down to what does that look like in, temporarily, in terms of like how does that develop on a day-to-day, we've moved to a quarter system, which is new for everybody here. We used to be on what's called a linear, as in you would do all 8 of your courses and it would run for 40 weeks. We're now in a system where we run on quarters. That means that the 40 weeks is broken into 4 10-week sessions. So each quarter is 10 weeks, and you do 2 courses at a time. This was, of course, to optimize the provincial health guidelines around keeping the number of students that are together to a minimum. So instead of having 8 classes that you're running back and forth between, you're really only 2 groups. So the way it worked out this year, it's hard to say, really impossible whether it would look like this next year, but the way it worked this year is the grade 8s had their ADST block in quarter 1. That's happening like currently. We just had a class today. And they would have some other course. And those are the only 2 they're doing in quarter 2, or in quarter 1 rather. And then in quarter 2 and 3, you've got your other courses, your core courses that are required. And then in quarter 4, we come back. So it's a bit odd. We've not done it like this before, but there's no way with the way the schedule's set up for these to actually be all together at the same time. So in quarter 4, we return to a STEM cycle and we're doing math and science. And I think one of the things I want to point out before leaving this is that, does that mean that you can't do interdisciplinary study? I mean, if you're only doing ADST, does that mean you can't talk about math and science? And we certainly don't feel that that's true. So the way we've done it is the ADST in quarter 1 is kind of the focus, but as you'll see, I'm going to show you a video, there's a bunch of math in that as well. So we're really making sure that the learning is serving the project and what the student needs to know for it to be valuable. So yes, the subjects are in different places, but they really do tie together. And so we let that serve the project. So here's what the technology would look like. Here's a sample case, and I'll show you a video of what that looks like. So here's today's situation. Your group is building a robot that will be able to solve a maze, but the robot's getting lost. So here's a coding problem. If the door is to the right and everything is okay, but when the doorway is to the left, the robot doesn't see it. Like, why is that true? And so, you might be looking at the coding to see if you can figure out what that looks like. So I have a slightly different example of that. I got students who are working on leading up to this problem. And in the next one is a video showing students getting to, their very first try at what does robotics look like. So this is a group of grade 8s from earlier today working on what's called an MBOT. Oh, right on. You're doing that on your phone? Oh, I guess, yeah, if there's an iOS on or if there's an app on the phone to do that too. Very cool.
So we're trying to test to see if our robot works, and this is like the floor map, and this is what we have to do. So we start here, we have to go around to A, come out to B, go around to C, up to D, and then back.
I'm being crashed into here. That's okay. And why are we doing that? Like, what are you trying to accomplish?
To test our robots to see if we can control them with the iPad.
Oh, okay. And then what's the next objective after that?
We're gonna try coding the robots to do this without controlling them with the iPad.
Oh, okay. And see if
they can do the same thing.
Oh, and with coding instead of direct drive.
Yeah.
Okay, that's very cool. Thanks. So you're seeing an example there. I hope that comes forward as students are just getting started with learning how to use robots. So the hope is that what they do is go from there to learning how to get to code it so that it can basically on its own learn how to solve a maze, which is really cool. So students tend to enjoy that. So that's footage of from earlier today of students in the grade 8 cohort, this year's grade 8 cohort, working on learning how to do robots. If you're worried, by the way, about well, gosh, what if I know nothing about robots? We assume that everybody knows, basically nothing, and kind of start from there. And it's what we find is that there's a little courage involved, but everybody makes it to the end, which is great. And so you'll need that resilience, but don't worry about having to know stuff ahead of time. So what does math look like in that? Because I have an example of that coming up as well. So one of the situations that we came in across last year is that the group is building a robot to solve the maze, and we found out that the motors, you can't actually control the robot by telling it to just turn left. You actually have to tell the motor to turn. And so they were having a hard time making it turn 90 degrees. So I'm going to show you. I had a conversation with a young man in one of the cohorts today, where he sort of explains what he's doing, and I like, you can see him working on the math. It's really cool. So just watch this a minute. So to teach it to turn left, you have to do some math here. What are you doing?
So what we're doing is, because we know that it takes this amount of repeats on our code.
Yep.
To turn 360 degrees, and since 360 degrees divided by 90 is so what we're doing is we're taking what we have here, and oh my god.
No, it's totally fine. It's hard to explain.
Yes.
Do you know what kind of math you're using there?
Yeah, so we're basically just dividing this again by, okay, so we have the 360, and then we have the 90, and that divided by 4 is 90, so we also need to take this, which 8.3 divided by 2.05,
0.75, yeah.
Sorry, that was wrong. 8.3 divided by 4. And that's how we found out, because you need to divide this by 4 to get to 90.
Yes.
We also need to divide this by 4.
You, sir, are doing ratios.
Yes.
Do you remember doing ratios in elementary? Did you guys do, what grade did you guys do ratios in? In grade 7?
No, I thought it was in grade 6.
Right?
We had to do it in grade 6. We did it in both, yeah.
Okay, that's good. Yeah, and learning where ratios actually fit in is a challenge, right? Like, it's one thing to learn ratios, it's another one to learn where to use it. So I hope what comes through there is that, what does it look to embed mathematics? And I think students often run into this problem where they've learned the mathematics, but they don't know where to use it, because it's often, to be honest, introduced in a way that is devoid of context, right? It's not introduced as something that is real. It's introduced as a pattern that may exist or may not. So there's always a little bit of struggle when people start that, but it's a lot of fun, and it really does pay dividends. And I'll get into that a little bit later. So our next one is, I wanted to look at one last example that people often like to see students actually in action. So I got one more short video for you. This is actually from the grade 9s. This is a couple of students that I worked with last year. Great students. They're doing a hydroponics program. They're basically looking at food sustainability in agriculture, and you can see they're using a flood table to grow microgreens. I asked them briefly as a group of 4. Can you explain, what you're doing? So just have a listen here. It's really cool. Sure.
Dry soil.
What are we doing here?
So we decided to make a system that would water itself using this moisture sensor. And the moisture sensor can tell if the soil is dry or wet. And then if it's dry, it'll water it. And then if it's wet, it won't. We wanted to do this project because, we don't, on winter break, we didn't want to have a teacher have to come in, so it can just water itself.
Okay, can you explain to me how the sensor works?
So there's electrons trying to go from this side to that side of the sensor. So it doesn't really work when it's in the air. So if you put it in the wet soil, then it's easier for the current to go through the 2 pegs.
Oh, okay, and so that's how it can tell whether it's wet or not?
Yeah.
Okay, excellent. Okay, so tell me how does the program control the whole system?
Okay, so the soil moisture sensor takes the reading and it sends it in to the Arduino, and the Arduino says if the soil moisture sensor reading is below a certain amount of moisture, then it's going to send a signal over to the pump.
I'm going to get you to explain to me what is this, and how does this work? Yeah. How does the water move about?
So the relay is practically a switch that communicates with the Arduino, which is that, and which also communicates to a pump, which transmits water through the dry or wet soil.
Oh, okay. Excellent. Thank you. Well, one of the things that sticks out to me in a situation like that is those are grade 9s, and it's so fun to watch what a difference a year makes in terms of students and their understanding of how electronics and tech works. They really do pick it up quite quickly. It's a lot of fun. So I wanted to move on to, so that's a window into what face-to-face looks like. And what about the online? So one of the things that you should be aware of is that there's going to be a component of working face-to-face, but also remote. And that's how it's working this year. So the students are, at times working remotely, and how do we manage that? So all the students will be connected to their teacher via Teams. And the thing that we're finding works well for students is that they need to have choice, because when you're off on your own and you're doing someone else's stuff, any bit of motivation that you can have really helps. So trying to balance choice with clear learning goals that relate to, STEM relevant subjects. And then the other key is support. The kids really do need support in order for that to work out. And that's especially true in the younger grades. So what does that look like? So here's a view. For those of you in elementary probably recognize Teams by now. In this case, the teacher, Carl Janzi, is working with the students and has a channel for them to go to. So that's where he would communicate with them. And the learning objectives, we called it a learning menu. The students are given some choice around, guided choice around, like, hey, actually, I'd really be interested in learning more about special topics in mathematics, or build a spaghetti bridge, or things like that, where they can pick learning objectives that relate to their grade level, but maybe fit their interests. And we find that that's been really successful. So they have an opportunity to choose from some menu items. And then the support piece looks like this. You got this lineup where in the morning, maybe you're in the morning cohort and you come in from 8:40 to 10:25. And there's this middle section in the day, which we call the flex time. And that runs from 10:25 till 1:15 in the afternoon. There is a break in the middle for lunch. That middle period of time is really key, because you need to have options for students if they're not experiencing success to come in and get the support that they need, like by just literally visiting. I need to see my teacher face to face. So that's always available. So do be aware of that. You're not on your own. For people where it's harder maybe to come in, we're also this year running online synchronous support sessions. So what that looks like is on, say, Tuesday, there, 2 times there will be an opportunity for you to use Teams to log in, and your instructor will be there. So that if you have any questions, that you can do that in a Teams meeting. So we do that 4 times a week. So that's plenty in terms of opportunities to be able to get extra help if you need it. So you're not on your own during that remote time. What do other projects look like? It's important for us to do a balanced diet. So when I'm selecting things to show you here, it sometimes can look like it's all tech all the time, or all physics all the time. We really do try to give a balanced diet. So there will be biology and chemistry and physics, sort of the main ones, and then some robotics and so on. So this is from a crystal growing one we did a couple of years ago. We've done a lot of stuff with compressed air rockets. Like I mentioned earlier, we've got like 150 different projects we've done over the past 8 or 9 years. So it's a lot of fun. It tends to be a fair bit of student choice in terms of them saying, hey, could we do a project on this? And so that's always an option as well. I wanted to move on to sort of the highlights. Like, so what, I could do STEM, or I could do a regular program, and that's fine. I mean, people can do it, but what we're looking for, how do we know this is successful? The number one thing for us is really student engagement. That's kind of like the big measuring tool, right? How do we find out if this is working? It's when the students are doing well and sort of achieving, especially when you look, outside the school. So one example would be entering the Spelman Clean Energy competition. We got some students that made a solar array that's basically designed to improve the efficiency of the array by articulating almost like blinds, on like window blinds, where you can move a cord and have them all move together. So they designed a system that would track track the sun and improve the efficiency of the panels instead of just having them mounted sort of rigid. And that took them all the way to the top of the Spelman Clean Energy competition. We were semi-finalists. Similar things with the provincial science fair. Really amazing results from the students, winning silvers and golds in the provincial science fair. And it's because they're choosing the projects and they're passionate about it. So that's always great to see. And there's the freedom to do that in the program. I wanted to look at math. This is sort of how I'm going to end things before we get to some of the details. And I can see I'm at 25 minutes already. There's always a lot of questions about math. This is probably the biggest sticking point, and I just want to give sort of like a fair heads up. The biggest sticking point for a lot of people is that math is going to look a lot different, and that's largely because, to be completely frank, I've taught math for years, and the way that I grew up with math, which is sort of introducing you to strategies and so on that don't have context, is really effectively not very useful. And I hear that message not just from myself, but from post-secondary and industry and people actually who've gone through math. So many parents I talk to say, it wasn't very effective for me. So the question then is, well, what does the new math curriculum look like in an authentic project scenario? So here's an example I can give you from last year. We did cardboard canoe races. So the goal was, to the grade 8s, I'm going to give you a big sheet of cardboard. We're going to give you a roll of tape, cutting tools, and the I guess challenge is, can you construct a cardboard boat, a card boat that will go as fast as possible without sinking as you race across a pool? So where does the math fit in there, and what does it look like when it's embedded? Sorry, I've skipped a slide. Let's talk about the competencies first. Like when you're doing a project like that, what stuff comes up? These are listed directly from the ministry competencies. Can you estimate? It ends up being really important to be able to estimate when you're designing like that. And then another one is modeling mathematics in contextualized learning experiences. What that means is using math to actually do something contextual. Like in this case, the context is build a boat. So that's directly from the competencies. Do these things, please, in your classes. Another one is use mathematical arguments to explain, justify, and support personal choices. So we get all the students to say, well, okay, you've designed this shape hull. Like, why are you doing that? And can you support your reasoning with mathematics? And it's a fun exercise. The students actually, it's a real challenge in terms of, in this case, optimizing volume. So what does it look like? What does the content look like? Because sometimes people are like, it doesn't look like you're doing math because I don't see the worksheets that I'm used to. Proportional reasoning comes up. So what that means is, I think I've skipped one. I'm double clicking. Percent is a topic in grade 8 that's comes up. Comparing the maximum mass that your boat held before sinking with what you had calculated it would hold. So when you do that and you get a percentage, what does that number tell you about your design? And it's really interesting to see students calculate percent and then think about it in that sense, like, what is this really for? So there's an element of analysis. Proportional reasoning is also really important in the content. Actually, the boy that we saw earlier who was talking about the MBOT is actually using proportional reasoning there as well. So it comes up all over the place. So in this case, if water has a density of 1 gram for every cubic centimeter, how much mass of water does your hull design displace? And that's the equation they're using. And they need to know the volume, and then they can work backwards and figure out the mass. So it comes up in the curriculum, and that gets modeled for them, and they learn how to do it. The last example I'll give you of content is volume and surface area. So my drawing capabilities are so terrible on doing this. I've got nobody's boat actually looked like that, but in this case, it would be estimate the volume and surface area of the following scow-shaped hull. And this is actually not technically a scow. So but they would look at a question like that and then have to figure out together as a group, like, well, how do we figure out the surface area? And it should have a little triangle off on the front of it. And it's a fun problem and level appropriate. So that brings me to, oops, sorry, I've done it again. Does it work? And I think the resounding answer is yes. What we found is that as we've moved our conversation about math from here's a targeted skill, learn it, or a targeted content area like SOHCAHTOA, learn it, when we've focused on problem solving, what we find is that when students engage in problem solving, external problem solving exams like the University of Waterloo exams, we do really, really well. So we've seen a huge increase in performance. And this is actually a picture of a young girl in grade 9 last year who scored top in the school. for the Pascal exam. So these are really great. The University of Waterloo is famous for putting out really high quality challenges that are really about, do you know how to problem solve? And that's what we're hearing from industry as well. We want problem solvers, not people who know just the formula. Which brings me to our industry partners. So this is a big one for me. We've worked with these guys since day one. If you've not heard of SAP, they're downtown in Vancouver, and they are a business software company based out of Germany, but they have offices all around the world. And this is the amazing team that we work with. And really what the relationship here is, it's sort of three pillars. We've got the school board, and then the teachers in the local school, and then we have an industry partner. And as sort of three legs, we're sort of looking at how do we best do curriculum and make that work. And then the industry is giving us key insights into like what sort of skills are actually relevant when you're on the other side. And that's a moving target. That's not something that's been the same year over year. So it's really great to have close contact with them about what they're seeing in the workplace. And we also we have post-secondary partners that we're in close touch with as well. But these guys give us a lot of help understanding, how the job place is changing. They also give us amazing program support so that we can, do all these amazing projects. And I think probably my favorite part is the mentorship. They send volunteer, and it's changing, of course, because of COVID, but they yearly dedicate 600 hours of employee time to spending with our students. And what that looks like is mentors actually coming through multiple sessions to basically talk around career pathways and skills and sort of how to imagine your future and what sort of things are possible. It's really been amazing, and I think the mentors enjoy it as much as the kids do. So it's been a lot of fun. Another one that's important to us is encouraging diversity. Everyone here will probably recognize that engineering and STEM fields in general have a bit of an issue with attracting a population of people that represents the broader public. It doesn't look like that. If you look into STEM fields, you'll see a lot more white and male faces, and that's an issue for us for sure. So we're looking at a number of different things, like how do we move the needle on that so that the group that we have in our classes actually looks more like what you would see in society. A couple of things that we're doing, and it seems to be working. So, for example, we don't have entrance tests, and we also don't ask for elementary report cards at the entry level. And what we're seeing is that the IEP, or individualized education plans, and diverse learners in the STEM program, actually the ratio matches what we see in the rest of the school population. So effectively, we're not selecting against anybody because of their learning needs. We also run events that focus on inclusion and diversity. So we've done Women in Science, and we've had people come from Science World and whatnot to meet specifically with the girls. We also have a Girls in STEM elementary outreach that some of our senior girls run, which has been a lot of fun. And I should also mention that we have complementary support structures and clubs within the school, so we don't need to reinvent everything. There's an LGBTQ+ and diversity club that exists in the school with this express aim of making people feel like they're a part of a community and they have a home. So that's really important to us as well. A last one that I'll mention, I guess, before getting to sort of the end is at the end of a program, what does that look like? Scholarships and fellowships are a nice way to sort of, is this working? And we're seeing students do really well. They've got, we have a much higher rate of students being successful in applications for scholarships and internships, largely owing to the project. When they really tuck into a project, that shines when they make an application, and so the passion really comes through. So we've seen a lot of success. We got a couple of girls there who won at the science fair. And we also have had a number of students go to study up at Triumph and also do internships at SAP. This is a case probably that this was a big one a number of years ago. The Loran Scholarship is the largest scholarship in Canada. It's a $100,000 prize. Our student Nick Murray was successful in his application and was one of 5 students chosen across Canada to receive it for a project he was working on early detection of skin cancer. So his senior capstone project, like his choice project in grade 12, was, I really want to see if I can find a way to more effectively find skin cancer at like early detection with a really cheap device that is easily available as opposed to having to go into a clinic. And it was just an outstanding result. It was a lot of fun to see him do that and make that. So that was the year 2018, a really outstanding result. So we really, the grads are accepted to programs of their choice, which is really lovely to see. For the first time ever, we've been getting calls from UBC to ask which of the students are from our STEM cohort because they want them in the program. So as I mentioned earlier, we're seeing an uptick on major entrance scholarships, which is great. And then what we see is when they move into their courses in post-secondary, they're successful, especially in anything to do with projects. They also receive early acceptance in special engineering teams, and we're starting to see the earliest cohorts that we taught in 2013 making their way into STEM careers like mechanical engineering and civil engineering and software design and so on. So it's really lovely to see. So in summary, and I've gone to 36 minutes. I blew it. But in summary, I think a question maybe to ask when you're wrapping up and okay, well, what did I think about this, and do I have any questions? I think maybe a good guideline is to ask, like, do you like to choose how and what you learn? And for a lot of kids, that actually isn't what you're used to. Like, you come to school and you get told what you're going to learn. So if that's uncomfortable, you're like, I wish I had more choice. That's a good indicator that this might be the right fit for you. It's not a requirement all the time to work with other people, but it is a key element. And I think what we're recognizing that is that in industry standard is that you need to have like 21st century skills and the ability to work with people. So that's a big push for us. And I think you're going to see a lot of that if you're a part of our program. And then the last one is, are you willing to try something new, even if you might get it wrong? One of the big lessons for us about the new curriculum is that it's not about whether you get stuff right or wrong. And we're not there to penalize you if you have a bad quiz. I mean, if you do another quiz and your response is better, then that's your new high level. So it's really important to us that people feel safe in a classroom trying something new and stretching yourself. That's really important. So let's get to the applications and what does that look like? So there's really kind of two, we're not a district program. So what that means is that there's a difference between whether you're in catchment or not in catchment. So if you're in catchment, as in within the school boundaries, and you can go to the VSB website to find out what counts as the boundaries, you'd have to apply by 3 p.m. on December 18th this year. Just want to reiterate that there is no entrance test and that the selection is made as a blind lottery. And so that means that your name gets put in and we spin the thing and what comes out is, maybe you're in and that, but it's lottery, not selection on the basis of any other criteria. The application form will be online. It'll be at this web address below. So if you go to templetonstem.org and you click on the How to Apply page, you'll see a place for you to enter your data and your intent to want to be in the program. So that'll appear there. So that's where you're going to go to apply. That's where you can make your electronic application. Slightly different if you're cross-boundary. So some of it is the same. You apply by 3 p.m. on December 18th. There's still no entrance test, and it is a blind lottery. The only difference is that the placements for cross-boundary occur after the in-catchment students receive their placement. So, maybe the chances are a little less that you would get in, but I can say that in every year that we've run the program, we have cross-boundary students in our grade 8 cohort, and actually we have cross-boundary students in every one of our cohorts. So it's not that there are none. But it does the placements in the way the school board structures the rules. We'd have to do your placements after in-catchment because we're not a district program. The lottery occurs. When do you find out? Let's say you apply and everyone is always biting their nails like, did I get it? Did I get it? The first date, what's called first offers of acceptance. So we do a blind lottery. February 17th is the first date. That'll be via email. So do make sure your addresses are correct. We have had problems with that in the past. February 19th is when you need to accept your first offer deadline. Once that's passed, if you've not responded because maybe you've selected some other program, then we would go to our second offers of acceptance. So we look at, okay, how many spaces are there left? We would do a second offer, and then the acceptance of second offer deadline is the 26th. So those are the dates where you should hear. And if you haven't heard by then, it's because the lottery process was full. So that ends it. I'm right at 40 minutes. Wow, that was longer than, I was a terrible estimate, Mr. Hengeveld. So for more information, you can go to templetonstem.org. We've got a bunch of program information and much of the same stuff as what I talked about here, just not in video form. Of course, you can follow us on the gram. We're at Stemstagram. That's where you'll end up seeing, past projects and some of the stuff we've done. And then I guess most importantly, if you have questions that weren't addressed in this presentation, my name is Mike, that's the M. Hengeveld. So you can send me an email at mhengeveld@vsb.bc.ca. And I would ask that, just have a little bit of patience. I don't know how many emails I'm going to receive. And I will try to collate it into a coherent question and answer that will give everyone an opportunity to sort of get answers to their questions. So it is a bit weird that we've had to do it like this, but I want to thank everybody for where are we here? I want to thank everybody for going through that, and all the best, I guess, in your application process. And that's it for me. I think I'm going to stop the recording, and take care.